This week we're getting into composition of functions. See, I thought we was about to do an English lesson when I was talking about composition. Composition of functions. So let's jump right into it here. All right, let's assume we've got two functions. I'm going to put f of x up here, 3x plus 5. See, that's just function notation, right? I could put y equals 3x plus 5, but f of x is the same as y. But I'm calling it f of x because with function notation, I can compare it to a separate function, g of x, which is going to be equal to x squared. So I've got two different functions, and so using function notation, I can name them f of x, g of x. So what does it mean when I put this? F of 1. Well, it was f of x, now it's f of 1. That just means we're going to substitute in for x whatever's in this parentheses, which happens to be 1. 3 times 1 plus 5. So f of 1 will equal 8. Right? Because 3 times 1 is 3 plus 5, it equals 8. What if I put g of 1? So am I going to substitute 1 in and get 8 again? No, this is the other function. So I'm going to substitute over here and say it's 1 squared, which 1 times 1 is just 1. Okay, so we understand that, we can do f of negative 3 if we want, or whatever numbers, but that just means whatever's in the parentheses substituted in here. But what if I do this? F of g of x. Now what are you going to do? Well, the rules don't change. The rules still work the same. Whatever's in this parentheses, we're going to substitute in for x. Well, what's in the parentheses? What's in the parentheses is g of x. So 3 times, instead of x, we're substituting this, x squared plus 5. So f of g of x equals 3 times x squared is just 3x squared plus 5. That's it. That's the answer. We can't go any farther than that. These are not like terms. We can't combine them. We don't have a number to substitute in for x. All we have is substituting g of x. Now, is that going to work the same as g of f of x? Come back and look at this again later in the video too. But well, if we do that, we're substituting f of x into g. So you're substituting 3x plus 5 in for the x here and squaring it. So when you square it, that's the same as 3x plus 5 times 3x plus 5, because squaring means multiply by yourself. So that's going to equal 9x squared plus 30x plus 25. So they don't equal the same thing. This one equals 3x plus 5. Sometimes they can, but it has to be a specific set of functions that will equal the same thing when you substitute them one into the other. So, all right, let's look at our notes for this week. So we've got the function notation here. F of x is read f of x, which means function of x. Simply that, function of x. It's a function of x. So let's look here. This is kind of like we had in the other page, 3x plus 6. What's f of 1? That's where we just substitute 1 in there. 3 plus 6 is 9. What is f of negative 1? Will be 3 times negative 1. So it's negative 3 plus 6, be a positive 3. Okay, so this works just like we were doing right here. I just used 3x plus 5. Here it's 3x plus 6. The same thing when you have a number inside the parentheses, that is what you are substituting in for x. Okay, what is f of 3 for this function? Here's the function. Joel says 9. Yeah, it's saying, what does the function equal when x equals 3? Well, it equals 9. Because remember, f of x equals the same thing as y equals. right? This is the same thing. F of x is the same as y equals. We just write it in function notation instead. So function notation changes to f of x instead of y equals. But it's the same thing. So if x is 3, then the y equals 9. So that is 9. How about over here? We got a graph. Let me zoom in. It's kind of hard to see that. There you go. What is f of 2? Yeah, throw a 4 out there. Negative 4. There you go. Good. Joel's got a correction. Yeah, this is negative 4 because 0 is up here. So it is negative 4 because when x is 2, this function equals negative 4. Right there. All right. So f of 1 would be, looks like negative 2 perhaps. F of 0 equals 0. So it's just looking at that and seeing what does it equal when that is the x value. Kind of level so it doesn't have trouble focusing. All right, that's probably pretty good. All right, so operations on functions. Functions can be combined with other operations to create new functions. You can add f plus g of x, and that means take f of x and add g of x to it. Right? Add them together. This is the same thing as taking f of x and subtracting g of x. And we're going to do some examples of that below. F dot g of x. That means takes f of x and multiply it times g of x. They multiply together. And this is taking f of x and dividing it by g of x. Right? F over g of x is dividing. So let's do some examples of that. So given h of x and j of x. So here's our function that is h of x, 3x squared minus 2, and f of x is 4x plus 12. They want us to do h plus g of 4. H plus g of 4. So how are we going to do that? How do we do h plus g of 4? Somebody give me an idea. H plus g, oh, j, I'm sorry, I keep saying g. H plus j of 4. Block out, most of the food there. So we're gonna. I don't know if y'all are asleep or lost this morning. Take a guess. If you don't know, just think. If you were given h of x and j of x, and then told to solve h plus j of 4, put 4 into the x of both. All right. So let's take the h of 4, which would be 3 times 4 squared minus 2. And j of 4, which would be 4 times 4 plus 12. So 4 squared is 16 times 3. So that equals 48 minus 2. So this equals 46. This one equals 16 plus 12. So that equals 28. So h plus j of 4 would equal 46 plus 28, or 74. So we just take that 4, substitute it into both equations, find out what those equations equal. Right? So you've got the h of 4 equation over here, j of 4 over here. Once you figure out what those are, then it says to add them together. 46 plus 28. Okay, here we've got h times j of 0. H times j of 0. All right, I'm going to give you a second to solve that and then put your answer in the chat. What is h times j of 0 for these equations, h and j? Have you got it yet? You're like, what? Already? Only because it's 0. That makes it a lot faster because it's 0. I see a 10 and a 0. I don't think either one of those are correct. I think when we work this, we're going to get a different answer. H times J of 0. I'll start it out for you. H of 0 equals 3 times 0 squared minus 2. So that just equals minus 2, right? Because there's a 0 being multiplied in there. Everything's just 0. I got you, Carmine. J of 0 would be 4 times 0, which is just 0. So that would just equal 12. Right? Because when you got 0, anything that has an X goes away because 4 times 0, 3 times 0. So H times J of 0 would equal negative 2 times 12. Negative 2 times 12 is negative 24. Just be careful. Don't jump to a conclusion. Solve it and then just do the math. Negative 2 times 12. Well, let's do. So let me give you a chance to redeem yourself. J divided by H of negative 2. That one's a little trickier. But let me give you a minute to try that. Then we're going to look at this in a different format here in just a minute. I'll start this for you. Going to find J of negative 2. And you got to find H of negative 2. Joel's got a 4. I haven't solved this yet. I don't know if you're right or not, Joel. So 3J is a 4 times negative 2 plus 12. H is 3 times negative 2 squared minus 2. So 4 times negative 2 is negative 8 plus 12. So J of negative 2 equals 4. Oh, Joel's saying 0.4 now. 3 times negative 2 squared. Negative 2 squared is 4. So that's just 3 times 4 minus 2. So 3 times 4 is 12 minus 2. So this equals 10. So J divided by H, here's J. 4 divided by 10. So that would be either 2/5 or 0.4. 4 divided by 10. We know this is 4 and that's 10. So the answer would be 2/5 or 0.4. All right, good job. Let's see some of you getting 0.4 there. I'm this one in the interest of time. Yes, go ahead now.
Do you want it in fraction form or decimal, or like does it matter?
Unless it tells you to do it as a fraction or a decimal, I don't mind too much. If it's a fraction where you're going to have to round it off, then leave it as a fraction. You know, if this was
Okay.
2/3, we'd leave it as 2/3. But since this one will terminate at 0.4, we'll go ahead and allow either way. All right, we're going to skip that minus one. You can do that. But let's look at this. Let's do it if we have graphs instead. So we've got f of x and g of x as graphs. And it's supposed to know f plus g of 3. So what is f plus g of 3 going to equal? Looking at our graphs. Again, make sure to zoom in there. so you can see that a little better. This is quicker. You don't have to do calculations of what f of 3 is or what g of 3 is. All right. Appreciate it, Jennifer. Jenny's having some problems there. I understand. You get bounced in and out sometimes. Joel's on 3. All right. Joel's quick on this. So you guys are lagging behind. So f plus g of 3. So f of 3 is right here. It's 2. G of 3, 1, 2, 3, is 1. 2 plus 1. Good job, Joel. Joel's on top of it. How about right underneath that one? F divided by G of 0. F divided by G of 0. Haley says it's 0. Joel says it's 1. Got another 1. So f of 0 is 4 divided by g of 0 is also 4. So what is 4 divided by 4? It is 1. Remember, this is division. We're not subtracting them. So that's division. 4 divided by 4. Yes, there you go. There you go. Haley's on it. And let's do this one this time. G minus f of negative 1. See if that gives anyone trouble. So you need to know what g of negative 1 is first. So g of negative 1 equals 5. Or, I'm sorry. Yeah, it's 5. Negative 1 is 5. And then f of negative 1 equals, it's 6. So g minus f is negative 1. A couple of you guys are on top of that quickly. You can also use tables. We can do equations. We can do graphs. We can do tables. So f plus g of 4 should be, this should be quicker than equations too, because we don't really have to calculate what those f and g's equal. Since we have a table, it tells us what they equal. So it's f plus g of 4. 42. Boy, Joel's quick on this. Mia's got 42. So f plus g of 4. F is 18 when x is 4. G is 24 when x is 4. 18 plus 24, 42. Just add them together. Several of you all had that. You're on top of that. Good job. F times g of 1. Let's do that. F times g of 1. Okay. Well, wait. Oh, Mia corrected herself real quick. She says, wait, negative 24. 6 times negative 4, right? Because when it's 1, that's 6. When it's 1, that's negative 4. 6 times negative 4, negative 24. Negative 24. All right, you guys are on that. I'm going to skip these because, again, I think you guys got the concept. And so in the interest of time, let's look in here. Okay, composition of functions. That's what we were talking about earlier back here on these notes. Composition of functions is when you substitute one function into another function. You see it written as f of g of x, or you may see it like this little circle in there. This is also f of g of x. There's two different ways of writing it. F of g of x. F of g. That's what that means, is f of g. So given f of x equals 3x minus 4, and g of x equals 7x plus 1, what is f of g of x? All right, well, let's kind of work this one together. So we're going to substitute, instead of x, this is where we substitute g of x in there. 7x plus 1 is substituted in for x minus 4. See, that's our f of x with g of x substituted in it. 3x minus 4, except for x equals 7x plus 1. We're just substituting g of x in instead of substituting a number. So let's simplify that. We got to distribute. 3 times 7x is 21x. 3 times 1 is 3. And then we have the minus 4. So f of g of x equals 21x minus 1. Because we had to combine the 3 and the minus 4. 3 minus 4 is negative 1. So f of g of x changes things a little bit. So evaluate the following. F of g of 2. Now, there are 2 ways to do that. You can substitute the 2 into this, because that's what f of g of x is. You can just substitute 2 into that equation. Or if you like, if you're more comfortable, you can substitute the 2 into g of x, figure out what that number is, and then substitute that in f of x. It will come up with the same either way. So let's look. If we did the g of 2 is 7 times 2 plus 1. So that would be f of 15, because g of 2 equals 15. And so f of 15 would be 3 times 15 minus 4. So that's 45 minus 4 is 41. Or we can jump straight into the f of g of x equation that we've already calculated. F of g of 2 would be 21 times 2 minus 1. 21 times 2 is 42. Minus 1 is 41. So you'll get the same answer whichever way you go. Either figure out what g of 2 is first and substitute that into f, or if you've already calculated what f of g of x is, then you can use that equation and just substitute the 2 into it, because that has already combined the functions. They've already combined the functions when we do this. That makes sense? Any questions on that? So this does the same thing with just negative 3 and 5. Oh, except this is f of 5. Oh, this we're going to do a little differently. This they're trying to throw a loop at us. So f of 5. So that means you substitute f back into itself. So in this one, let's go ahead and calculate what f of 5 is. 3 times 5 minus 4, which equals 15 minus 4. So that equals 11. So now we have to take that and put that in there. So that would be f of 11, because f of 5 equals 11. Sorry, move that over. F of 5 equals 11. So what's f of 11? F of 11 equals 3 times 11 minus 4. 3 times 11 is 33. Minus 4 is 29. So f of 5 is 11, but f of 5 is 29. You have to pay attention to what they're doing. Now look at this one. G of f of negative 3. This one goes the opposite direction of this one. This was f of g. This one's g of f. So we have to substitute into f first and then substitute in the g, because we have not figured out what g of f is. This is f of g. That's different. That's different than g of f. In fact, if we want to figure out what g of f equals, g of f of x, we can do that. We can say g of f of x. So g is 7 times x, which is 3x minus 4, plus 1. So we'll draw a line, separate these out. So 7 times 3x is still 21x. 7 times negative 4 is negative 28. And then we got the plus 1. So this is 21x minus 27. So g of f of x is 21x minus 27, where f of g of x is 21x minus 1. So you would need to use this one for this, or substitute negative 3 in, and then whatever the answer is, substitute into g of x. All right. So they do the same thing down here, except for now we're dealing with a square root and a squared. So we probably need to work some of that. Let's see. So f of g of 16. Let's do f of g of 16. All right, f of g of 16. Oop, Laura, your microphone is on and your door is dinging. Okay, so g of 16. Let's figure it that way. Equals the square root of 16. Now, for these purposes, we assume the positive because we know there's two answers to that, right? It's 4 and negative 4. But when you're doing these compositions, you assume the positive. So it's going to be 4. Otherwise, we'd have two different answers. So we just assume the positive. So f of 4 equals 4 squared plus 2 times 4 plus 1. So that's 16 plus 8 plus 1. So that equals 25. This equals 25. F of g of 16. But going the other way around, g of f of 4. So we got to find f of 4 first. So f of 4 equals 4 squared plus 2 times 4 plus 1. Now we just found what f of 4 was right here, right? F of 4 equals 25. So then we need to find g of 25, which is the square root of 25, just 5. Then you can do f of g of 100. 100 be the square root of 100, so that'd be 10. So you'd find f of 10 for that last one. All right, let's just look at these 3 right here. We have a table this time. F of g of 0. All right, don't get lost in the table here. Just think about what that's asking. F of g of 0. So g of 0 is equal to, let's see, here's 0. So g is the second one. So it's equal to 4. So that means you need f of 4 because g of 0 equals 4. So we're going to go down here to the 4 and then see what f equals. So that equals negative 4 because that's what f of 4 equals. G of f of 3. So f of 3 is 1. So g of 1 is negative 4. That's also negative 4. Interesting. Then f of g of 5. G of 5 is 3. F of 3 is 1. So you just follow the trail. Don't rush through it. Make sure you're choosing the right number from the table. And then let's look at the last problems here. So often you'll see that composition indicated with a small circle. Like I said, this is the same thing as that. F of g is the same thing as f of g of x. Right. These are the exact same thing. And g of f is the same thing as the g of f there. Exact same thing. So you'll see this a lot of times instead of the other way. But this is the exact same thing as saying f of g of 5. Don't let that fool you. They write it differently. Exact same thing. All right. So we're just going to substitute 5 into the g. 2 times 5 is 10 minus 1. So this is the same thing as f of 9, because that's what g of 5 equals. So 5 times 9 minus 4, 45 minus 4, that equals 41. So the same thing for there. And then there's 4 more on the back. Let me write the equations back on at the top of the page of what we were using. Let's see, f of x was 5x minus 4, and g of x is 2x minus 1. So I do want to look at these last two problems here. 5x minus 4 and 2x minus 1. F of g of x, and then g of f of x. Okay, this just says that's the same thing, remember, as f of g of x. Oh, my g went a little crazy there, didn't it? Woo. And this is the same as g of f of x. So it's just saying substitute g of x into f of x, because we don't have a number. So we're going to take g of x and substitute it in for x. So f circle g of x equals 5 times, we're substituting in 2x minus 1 minus 4. 5 times 2x is 10x. 5 times negative 1 is negative 5 minus 4. 10x minus 9. Now, how about the other way around? If we substitute the other way, that's going to be different. G of f of x equals 2 times, here's f of x, we're substituting it in, minus 1. Okay, substitute it in. 2 times 5x is 10x. 2 times negative 4 is negative 8. And then minus 1. Look at that. One of those rare times when it equals the exact same thing. Yeah, we did one of those over here. Where did we do that? It's been back on the front page. Oh, it may have been on our example. We did that in our example, where we had 3x plus 5 and x squared, and it ends up 3x squared plus 5. But if we substitute it the other way, we would have g of f of x would be 3x plus 5 squared, which is going to be 9x squared plus 30x plus 25. See, that's very different if we go g of x, and f of g of x and g of f of x are very different in this case. And most of the time they are different. This is one of those rare occasions where they end up being the exact same equation. So don't expect this to happen. It does not happen very often. Most of the time you'll have something like this where you got two different equations when you combine those. Anyway, let's look at our assignment. Composition of functions. So it's going to be, I think it's 5 problems here, or 6 problems. I think 6 problems. And they are just about given, here's w of x and z of x, and it gives you those equations. And what is the value of w of z of 7? Here's g and f. What is f of g of 3? H of k of negative 2. So all of these are similar. They're just composition of function problems. And there's just 6 of them. They're worth 5 points each. It's a 30-point assignment. So just like our examples, should be able to do that. If you have questions, you can go back and look at this video, look at our notes, see how we did that. You can always email me if you're stuck and can't figure that out as well. But it's just simply following the trail. Whatever's inside has to be done first. What's in the parentheses? F of G of 3. You need to do the G of 3 first. It's the inside the parentheses part. And if G of 3 equals 0, then you do the F of 0 next. But start with the inside, work your way out. Start inside the parentheses, figure out what that is, work your way out. So, all right, that's all I'm going to keep you for today. That's plenty. You got your assignment for the week. Thursday, we may do some more examples or take questions or do what we need to do. But working with functions and composition of functions. So we will see you guys Thursday.